good afternoon, everyone. I think we can continue the session. So at 2 p.m. we will have Jorge coming in, and I will present Jorge in a couple of minutes. Are you ready to go, friend?
Yeah.
Okay.
I don't have any choice. No choice. So.
Yeah, we know where you stay, so
yeah,
you better deliver. Yeah. So let me take over the screen now. I want to introduce. Okay, so now for this afternoon session, we will have the pleasure of having Jorge Benitez. Just a few words. I think you will introduce the company. So just a few words. So he's one of the founders of Enzyme. So if you go to their website, you can find more information about them. So having two Jorges there, this is the one that we'll be talking today. So if you guys want to find out some more, you can go to the website. You can contact them at helloweareenzyme.com. They actually been working quite close to us and some of our clients by providing this digital consulting, where they would, try to see where all these digital solutions can fit in on the company's workflow, to make them work more efficient and all this. So they've been doing actively this across the Southeast Asia region and even with some companies in Europe and US. So in case you guys want to reach out to them, any company for any kind of collaboration, we think that they always add a lot of value to it. So I think now I would give the stage back to Jorge then, and the show is yours. I'll be here together with my colleagues, Chiram and Carlo, to answer your questions. If you guys have questions, you can type them in the chat of the event. So feel free to reach out to us for anything. So Jorge, I think the stage is yours. You can share the screen and do your magic like you normally do.
Thank you, Marcelo. I'll try my best.
Yeah.
Okay, so you guys can see my screen now?
Yes. Yes, go ahead.
Okay. So thanks a lot, Marcelo, for the kind introduction. Thank you as well to BCA and for Graphisoft to be so kind to keep on inviting us to these events. We're super happy to be here with all of you and share our humble work with you. So I'm gonna start the presentation with sharing with you a little bit about the company as well as some of the projects, some not so recent, so probably some of you might have seen them before, but some of them are quite new. And we're gonna end with sorry, let me just change this, with a practical exercise that actually comes from one of the real projects that we've been doing lately using this computational design approach. And yeah, I hope you enjoy. So, well, for the ones that don't know us, the company's name is Enzyme. We're a BIM architecture office. My name is Jorge Benitez, as Marcelo said, and I'm a Spanish architect, but I've been living in Hong Kong for almost 8 years. And I have been traveling extensively, mainly in Asia, Singapore, Japan, China, working with some of the best companies in this region, and working together with them in projects and helping them as well to develop these workflows. We are mainly designers, so that's kind of our thing. So we are all architects in the company. Our background is architecture, but we have become with the practice and with the years these digital consultants that I don't know if the word or if the work description is actually exist or not, but this is kind of what we do. We started doing mainly BIM. So me and Eugenio and Jorge, we started the company with the idea of this maybe perhaps a little bit naive idea of changing the world, right? But what we wanted to do is bring together design, good design, with efficiency and innovation. We saw that the industry was lacking this. So there were some companies doing very, very good design. There were some other companies being very efficient, but there was like a gap between those two concepts, right? So we wanted to do that, and within the company, what we do is, okay, we first focused on high quality design, of course, but that's not enough. So we have come to learn that is not enough anymore. Many people are doing good design, and so we have acquired the responsibility, or given ourselves the responsibility of improving and enhancing the way we work every time. So every project becomes research, every project becomes a journey where we try to implement and expand the knowledge, the skill sets, and try to, to be more sustainable, not only for the environment, that's one of our key focus, but also economically sustainable, the projects for the clients and for us, and etc. So because of that, we are all the time looking into new technologies, as of course BIM, but computational design and real-time rendering, GIS. We keep on developing like smart workflows, trying to integrate all these technologies. So the team is actually, we are a quite small team. We have offices in Hong Kong. Hong Kong is the main office, and we have as well a small office in Madrid, because the three founders were from Madrid, and we have offices in Madrid and in Singapore. That for some reason I'm not saying it here. I think it's out of the screen. But we have an office in Singapore as well. These are a few of the projects that we have been developing in the last 3 or 4 years. The company is 6 years old, and we've worked in a variety of projects and scales. So from master planning to architectural scale, where we have completed some of the most interesting projects, as well as interior design, where we have done a few, especially co-working spaces and offices in Hong Kong, but as well some residential. So I think you will see this in our presentations a lot. This is one of our main slides. I think probably the first slide that we ever created, and this is our tagline. We do BIM for design. We use BIM for design. So that's the most important thing for us. And then with the knowledge that we acquire while using BIM for our projects, we have created like a database almost of workflows and ways to work. And we try to support other companies in the creation of these workflows. So whether it's BIM or integration of other technologies, we can do that. We have done that in several occasions. With our longest collaboration in that sense was with Takenaka. We spent almost 2 years helping them and collaborating in different projects. So we did over like six or seven projects together, some competitions, some real projects. And we helped them as well to develop a BIM workflow and template for the design team to work with Archicad. So they had a team in the like detailed design and construction phases using Archicad already. They were very proficient, but they realized that the design team was not engaging with the BIM workflow, and they wanted to streamline that process. So we spent these 2 years with them. We have also done a collaboration with ADAS in Singapore. We had a really successful run of a few months working together with one of the teams there in ADAS Singapore, and I believe, I don't know if there is someone from ADAS there, but I believe it was quite successful. So I think this is something that, as Marcelo said, we can do. We will continue doing as long as there is a need in the industry to improve. So Graphisoft really kind supporting us since the beginning, because Archicad is the main tool that we use. We've been using this for over 15 years since we were in university, and we have developed a very, very good knowledge of what the tool can do, what cannot do, and whatever cannot be done, or it's better to do somewhere else. We have also developed a number of solutions around Archicad that can help us to create the best design and the most optimal. So Archicad is the best tool probably in the market to integrate other softwares. It can export almost any kind of file, and also it can import a big number of files, including all the most important, and there are plugins and add-ons to import and export Revit and 3D Max, etc. So we are not afraid to work with anyone in the industry that work with any type of software, because there is always a way that we can create an optimal workflow together. In our case, for our practice internally, we use Archicad and Rhino as our main authoring tools. We use Solibri for all, for quality control mainly, and help with Bim collaboration in larger projects mainly. And then we started using Cinema for visualization, but more and more we're moving into real-time rendering. So Unreal, we're trying to develop an Unreal pipeline and workflow to streamline as well. But we mainly, for most of our daily renders and animation, we use Twinmotion. That is really great. And then some of the tools we will mention them later. So being so small and being so young, we have participated and worked on more than 160 projects in the last 6 years. And as I said, in various scales. So we're very proud of this. So anyway, as I said, a few of the clients we've been working with, from developers in different parts of the world, Swire or Lotte in Asia, Imar in the Middle East, Oliver Wyman as well. And then we have also participated and collaborated with a number of architectural engineering firms like ADAS or Takenaka, Woods Pagods, KA in the US, PLA as well in Hong Kong, and Architect 61 as well in Singapore. So we have a lot of experience in collaborating with other firms. And we are very involved in educational and training. So we engage in various workshops and courses in Hong Kong, in Taiwan, and Singapore. And me and Eugenio, we also professors in the SIGGRAPH Global Institute of Technology, teaching the BIM management, international BIM management course. So we're very involved in trying to bring the industry forward in this sense. So just to move forward a little bit, I want to talk about two key things on this presentation before we start. One is the use of BIM to communicate our ideas. So in terms of using BIM for design, I think this is one of the most powerful things that we can do. Of course, we can be efficient. We can be fast. We can be precise. That's a given. That's the BIM platform. But one of the best things for that the use of BIM is to help us as designers to communicate our designs and to communicate ideas. So one of the things that we love about Archicad is that help us to communicate better. So we try to leverage this power of 3D documentation as much as we can in every project. So we don't use anymore only to the plans, the sections, elevations, etc. Because that most of the clients, most of the people that we have to communicate the design to actually don't know how to read those documents. So this can really help to improve the communication with them, engaging them in the design process, as well as creating a faster methodology for decision making process. So this really helps to speed up this decision making. So not only like 3D document, but also quick renderings from Archicad. This is one of our first projects, or even like substituting like all this workflow that was very, very typical in the 2D, 3D workflow using AutoCAD and SketchUp or Rhino, and then Photoshop or Illustrator. So these images that you have on the screen now is part of one of these collaborations with Takenaka, where the goal of these projects was to create everything for this competition in Archicad. So there is no Photoshop in these images. Like both the exploded axle as well as the 3D section and the sections, they're all created with native Archicad elements. So library parts like the trees, etc., or using graphic overrides or using gradient fields to create these gradient effects. They're all inside the Archicad file. So this made really fast, and actually it made that the team was focused on mostly on the design and not kind of like importing and exporting and creating these workflows with several softwares, and they're mostly outdated every time that there is some change on the design. So it was very successful. Again, creating, instead of plans, giving the clients these 3D plans, it helps a lot for them to understand what is the design. And this for us as designers is free. So we don't need to spend any time doing this. We just need to create like a section of the model and have a print screen, and that's it. So for us, the cost is minimal, but the impact on the client side is maximal. Same as, for example, creating these sections. This was all created in Archicad. So 2 3D documents put together on a layout and just like an arrow. So very fast and very, I think, at least for me, very visual, very impactful. Also, when we're talking about just simple documentation, just the fact that we are able to create these like Photoshop-like drawings, it really helped us well, not having to go back and forth to many other softwares. And at last, in this part of the presentation, the Twinmotion and Unreal integration, I want to show you one of the latest projects that we've been. It's a competition in here in Asia somewhere, and then we created this animation in a day with the Archicad model.
So this is all rendered in Twinmotion, is it?
Exactly. This is a Twinmotion.
Twinmotion 2020 or the previous?
Can you repeat?
If it was Twinmotion 2020 or the previous or 2019?
This is 2020. This happened like 2 months ago. So it's not the latest version of Twinmotion, but the previous one. So it's the 2020.1, I believe.
Oh, okay. That's quite impressive.
And this whole project was done, the project, the renders, the animation, everything within a week. I mean, it's not a big project, and everything was done internally in the office. So
you didn't have to go and hire like a rendering expert to
no, exactly. So once the project was finished, after a few days, we just put it in Twinmotion and spent a day playing with materials and vegetation, etc. And one of our guys just put it in Premiere to add the music and to create like a little bit more of like professional look. But that's it.
Okay, very good. Well done.
So, well, I don't want to spend more time of this, but I believe that this can be something really powerful for for every practice, I believe.
Yeah.
So
More and more, you can do the renderings yourself. Yeah.
yeah, I mean, we still use render companies, but only when we need like a very I don't know, like
High
professional,
quality.
yeah, and high quality for the everyday rendering jobs. I mean, for every project we need to produce, I don't know, an average of 50 renders in total, because every time we're trying new designs or new iterations, comments, etc., people want to see how that looks. So if we have a tool that is, again, almost for free for us, free not in terms of buying the software, but free in terms that we have to spend very, very little time, then it's really worth it. So anyway, moving into the computational design, this is the second thing that we love about Archicad, and we love about the work we do. Is that lately there is this trend in architecture, I think, for the last, I don't know, maybe 5 years, where we're bringing this concept of parametric thinking. So that means, so that also includes Bim on it, at least in my perspective. And this is changing the way architects are, especially young architects are designing and are aligning their thinking process. Is very different from the old school way to do architecture, and I don't think it's better than one than the other. It's just different. The fact is that we think about everything that might affect the design, how things can change, if there is change, how that change is allowed on the design, and then therefore we create like these logics that that actually apply as well for old school projects. The only difference is that we don't write those logics anywhere. There's like a concept idea for the project, and there are things that are aligned with that concept and things that are not aligned with that concept. And that's kind of like the logic that every architect know, like internally. But in this new parametric thinking, we write all of those in scripts, and then we can play with with all these opportunities that fall within those parameters, right? Also, these tools are creating the opportunity for both clients and designers to explore more and have more flexibility, right? So other thing that is relevant, I think, for this type of architecture, or this approach, which is the computational design, is that we can create complexity, not only like formal complexity, maybe it's programmatic, or maybe it's a different type of complexity, and use the power of the computers to help us break down this complexity in parts that we as humans can understand and can play with. So fields of application of these technologies can be this parametric driven design. So imagine we want our design to depend, for example, on the sun or on certain environmental conditions. We can apply that and explore different solutions. We can use it for form exploration and have this freedom of design. Something that I really enjoy and that I'm learning more and more about is the next two, optimization and fabrication. So we can create algorithms that take algorithms that are inside the design algorithm. So you have your design algorithm, and inside that you have a few of the nodes or a few parts of those scripts that are helping you to optimize. So you giving a certain type of goals, for example, minimize volume or maximize sun exposure or minimize sun exposure. Or you as a designer can decide which goals do you want your design to reach, and then you can use the tools like, for example, this one that is called Walacy. It's a improved version of the Galapagos tool that Marcelo was showing before. Those tools are called are based on evolutionary genetic algorithms. So apply biological theory of like genetic theory that in biology, and they are applied into architecture. So practically they found the best solution in each iteration of their call generations, and then they sort of combine those good solutions into a better solution, and then into the best solution, right? So you can optimize for one parameter or for multiple parameters. This Wallasey, this tool is optimized for multi-variable solution. So so it's something very, very interesting, something we've been using lately as well. So in terms of form exploration, something that we really like about this live connection, the Rhino Grasshopper Archicad connection, is that you can continue. Obviously, Rhino, it might be the best tool for this job, because it has all this freedom of the NURBS modeling. Now, actually, in the new Rhino, this new version, you have the subdivision modeling as well. That is really, really interesting. But things in Rhino or in SketchUp, in these modeling tools, even Blender or 3D Max, they're just geometry. And by using this connection with Archicad, we can create those fast prototypes while maintaining the integrity of the BIM models. So keeping the information and keeping the model integrity ready to go for a coordination process with other softwares, for a BIM submission, etc., etc. So it's something very, very interesting. And as I was saying, for example, this project that you might have seen before, like a small capsule, but you can create these workflows to optimize for fabrication and assembly. So I think for this integrated digital delivery concept, this whole workflow using Archicad, Rhino, and Grasshopper is really, really good and very optimized. So our typical workflow, you can see here on the screen, would start, for example, in Archicad or in Rhino, where we start playing around with very, very simple lines. So lines that can become later on in Archicad, as you can see here, these lines might become slabs, might become beams, might become balustrades or curtain walls or whatever. But keeping it super simple. Like if you notice, I'm gonna just like stop here. Oops, sorry. I don't know if I can stop the video, but these lines, I mean, we're playing around with like an extremely light Rhino model. But this line in Archicad, and this is something that I like to call or think as a double parametricity. So the overall shape is parametric in Rhino Grasshopper, but those lines that can be changed in Rhino Grasshopper, once they enter in Archicad, they can be many things. They can be walls, slabs, and beams almost at the same time, and they can also be parametric in Archicad in the sense that they can change the level of detail without changing anything. In Rhino Grasshopper, they can like start adding more and more detail, for example, by changing a simple beam for a complex profile beam, etc. And then they can become something extremely detailed with a very few lines actually modeled in Rhino Grasshopper. In this process, we use this data-driven design. So what we do is, by creating a proper template for design, we can track, for example, in this sense, we can keep track of every iteration of design by using schedules, for example. We can insert properties from Rhino Grasshopper, and as well, if we have this prepared on our file, on a template file, we can leverage the power of this information that it is parametrically embedded from Rhino Grasshopper. We can create graphic overrides that give us this automatic diagramming and labeling, for example, to create these diagrams. Obviously, if the design changed in Rhino Grasshopper, it will just update, and the 3D document that was created using this graphic override, etc., will just update with the new design, new colors, the legends, everything will be automatically done. So this is one of the, I don't know, very simple workflows, but very, very powerful. Obviously, if you have this file set up, you can get iterations of sections, elevations, and schedules for each of these iterations that can, I mean, you can have maybe 20 options within an hour. And these 20 options, if the Archicad file is properly set, you can have almost like a concept design documentation package almost for each of these 20 options. So, and they are updated every time all together. So this is really powerful for us. Similar to, for example, 3D views, etc. So this particular exercise that you're seeing on the screen, this was a model developed in another webinar live, and this happens within 1 hour and a half. So from the scratch, creating the Grasshopper model to having this level of detail in 1.5 hours. And the most important thing is that this was not like a one design. It was like a family of designs. So by changing the script, you could create any similar tower. So another of these advantages is that you can, by using this plugin with Rhino Grasshopper, you can bring the even models that you have developed in Archicad, they can be imported into Rhino Grasshopper and then run, for example, analysis using Ladybug and Honeybee, or using other plugins as well. We can assess how the different constructive solutions or they impact our design. So it's like a both-way channel. In this case, we were trying to assess two things. One, it was like an architectural language for a facade, as well as trying to optimize the number of and the size of these sun shading devices in the facade, calculating the shadows projected from other buildings, as well as the sun path. So this created a very particular and very interesting language on the facade, but it was also optimizing the cost, the construction, the material, etc. So, I mean, it's good for many things. And I'm going to show you very quickly a few of the case studies. Some of them, you know them already. So probably going to go a little bit fast. This is one of the first projects we did using this connection. This is almost 5-year-old. We wanted to create this fluid form of a wave in front of the coast. And this was very difficult to achieve in Archicad. So this is specifically when we start learning Rhino Grasshopper. Our client was a hotel developer that had a very hardwire typologies of rooms and specific sizes and layouts that they wanted to use. So we just said, no problem, just give us those layouts, and we included, we hard code that into the script, and that was our starting point for the script. And by using and moving those modules, we created this, in my opinion, interesting volume and facade. And we use also Grasshopper to obviously to send everything to Archicad, and in Archicad happened the documentation process. So we were able to create floor plan diagrams, as well as area schedules of each of these options, as I said. And then we worked in specific architectural features like this facade here, using this rotated fin for the sun. And you can see how from Rhino Grasshopper to Archicad, there was a seamless connection. And in Archicad, we don't have Rhino elements or imported elements or weird elements. We have proper columns, and we have proper Bim elements. So this is a view, a project in Malaysia that we did, located in the middle of KL, and the project was located in a beautiful area of jungle near the communication tower. And you can see as well the terrain was very, very steep and quite difficult to work. And the goal for this project was to build a 500,000 square meters residential project. So that will mean probably destroy most of the jungle and create one of these typical typologies. So we wanted to create something different, and we went to we thought about this idea of breaking the podium, and breaking it down into smaller parts and bringing it to the upper levels, creating those bridges. and having only anchor stores in the bottom of the towers, that we wanted to keep them very thin in order to maintain as much as possible the jungle or the landscape, if not the original jungle, but at least to keep this flow of vegetation underneath and bringing this space to the city and as a park. And in order to do that, we needed to understand very well the terrain. And so we developed this script that helped us to find the best areas in that terrain or the most flat areas in that terrain in order to build the towers without much site formation works. So this is one of the things that we were very, very proud of. And then obviously we can use Grasshopper as well to assess, the different volumetric versions of the towers. At the end, this script became quite large, but we've ended up sending all the basic information to Archicad, where we continue the development. You can see the Archicad screenshots here as well. And in Archicad, we were able to leverage the power of this information coming from Grasshopper, creating these quick diagrams, track all these different types of floor plates, of rooms, apartments, etc. Then we developed like a few hot link modules that then became the whole project. And as I said before, one of the best things of working with Archicad is that in any time of the project, we could just like stop, create like these marquee sections, and getting out these beautiful 3D documents that were, explaining maybe certain areas that were not so easy to explain with floor plans and sections, especially in such a complex project. And again, very, very easy to explain to the clients. And this is just the last piece of the presentation. Sorry, I'm running 5 minutes late already, but this sort of like engage with the next part.
It was very interesting, so it's
Yeah.
okay.
The only good thing is that this part is will engage with the exercise. So I think we have time. So this is one of the latest projects we've been working on. Quite complex Bim model. This is I cannot reveal the much about the project, but it's an aquarium. So it has a lot of different components, from architectural or structural to like a very specific traits, like the people that are the aquarium specialists that have a lot of weights as well in the whole decision process. And we're doing the architectural and interior design works for this project, as well as carrying the BIM model and doing, I don't know, kind of like we're the hub where every other consultant is plugging their models, etc. So in the interior design scope, we had to create a few design items that required of this computational design approach. One of these items are the columns. So because this aquarium is not a standalone building, but it's inside another building, we had the problem of having a lot of columns. This is in the ground floor, lower ground floor of one building. So we had a lot of columns all around. I mean, all throughout the plan, and we couldn't avoid them. So sometimes they were quite annoying. So we decided for certain parts that where the columns were exposed, we wanted to make them disappear. And we had all these, in most of the walls, there is like this almost like rock work forms that are, almost like creating this ambience to the different ecosystems. So we decided to create like this a little bit more refined and modern interpretation of that in the columns by creating this triangulated shape that we will cover in the end. You can see here with reflective material And the idea is that, with all the reflections and the darkness of the space, it will almost disappear on the space, right? So we created a few versions of it, and at the end, when we were close to this detailed design phase, we needed to think about a way to reduce the cost and simplify the constructions of these items. So what we did is we ran this, we created a script in Rhino Grasshopper that will, first of all, optimize the size of these pieces, and as well as creating a logic or a shape that will allow us to create a minimum amount of different pieces, different columns, but by creating an asymmetric rotation to the column, it allows us that we could place this column in different angles, the very same set of pieces, rotating them in plan, it will create the effect of having different designs. So that was the first successful decision, I think. And then the second one was to create this script that helped us to automate the scheduling and the auto dimension of all these pieces that at this point are almost ready for digital fabrication. So you can see this is so we designed this column in the main column came from Archicad. Then, so you can see here, the wireframe model is coming from Archicad. Then we designed the yellow part in Rhino Grasshopper, and then documented in Rhino Grasshopper, and then we send back the model into Archicad, of course, for spatial coordination, and also we put so you can see here Rhino Grasshopper and Archicad, where we placed all these schedules in the layout together with all the rest of the package. So also the columns were important to create all the internal elevations, etc. So this is one of the items, quite simple. In the same space, we happen to have this, this very large area where there was nothing, and then the client asked us to do something for that area, and that was in line maybe with the rest of the space. And being part of a ecosystem of rainforest and etc., we proposed this idea of having almost like this swarm of fireflies or butterflies that the client liked. By the way, this is the exercise that we will be replicating just after this. So we went into Rhino Grasshopper in order to, because the idea is that, okay, we had in mind what we wanted, but obviously we had a number of items in the room, like the columns, like the other condition was that the space was going from one, I don't know if, well, you can see it here as well because it's the same space. So we were coming from a upper floor, and then suddenly the space dropped one more floor down. So it was like expanding. So we wanted to create, like bring the attention of the visitors, sort of like go with them together, like bring them down into the escalator, as well as redirecting them through the space, through the different exhibits. So this is that's we wanted to have, like, and try and see how it looked. So the approach was to create like a 3D path in Rhino Grasshopper. Actually, this is in Rhino. The 3D path is like an actual line in Rhino that we could control. In this 3D path will trigger from a grid of points in the ceiling. They will just drop down in, to touch the height of this path. So we also applied a few nodes that I will show you later to randomize a little bit and to create like a sensation of more organic and more fluid. And then we also had to, this is also in the context of the detailed design package. So we were already quite advanced, and we needed to explain what was going to be the assembly process and and the construction process. This is not going to happen today in the script. I think we will see it in another session. But one of the important parts was not only to create the design feature, but also to create a system that could be modular, that could be easy to put together, easy to maintain, etc. So we came up with this idea of these square modules with subgrids, and we mapped every single light into one of these intersections of the grids on top. So we could create all these panels offsite, and then just coming into the site with the pre-assembled panels, and then put them together. So we created as well like almost this map of where we had like a coordinate system internal for every panel. We created the naming system for the panels and the naming system for each of the lights, and all that was done at the moment was done in Rhino Grasshopper. Carlo is going to show us how to optimize that using Python and in Archicad. So this is how it looked, the detailed model in Archicad with all these grids as well. And obviously we needed to later on create a schedule to have each of these lights and understanding what is the length of each of these elements, etc., and in which location in which panel, and in which X and Y coordinate for each panel. So we created this schedule very quickly once all the information was coming from Grasshopper. And you can see here a few images. I think I'm going to jump this one, so we can just jump right into the project. So if you allow me, I'm going to just quickly. I mean, I can run through it, but I don't want to spend much time. This is another feature of the project, but this is quite complex. So it was a complex area. We decided to create this Voronoi ceiling, and we did a quite complex Voronoi script, and this was successful for the design submission. But at some point, you can see here some images of this idea. But obviously, for the design submission, we had this quite randomized. We didn't really think through the Voronoi. It's like a random, comes from a random system. It's something very natural, very again, very fluid, very randomized. So we didn't think it through. But when we went to I don't know if you can see on my screen, but the pattern is very, very randomized, and that gave us a lot of problems creating I don't know, like an almost infinite number of different angles, different joints, etc. So when we move into the detailed design process, we run one of these genetic algorithms that I explained previously in order to optimize the shape of the pattern, as well as minimizing the number of different nodes, the length of the panels, etc., etc. So I think, in my opinion at least, even the aesthetics of the final result, the final ceiling, have improved a lot. You can see here in detail, like what is the first approach, and then the final solve approach. And this is one of these images from this genetic algorithm, the tool called Wallasey. If you haven't looked at it, just go and check the website they have. It's a free tool, so it's really incredible. Anyway, these are a few images of the process, and by the end of the submission, we also played around with GDL, like custom GDL objects that we placed in Rhino Grasshopper. So the objects were created in Archicad, obviously, simple objects that were like this circular plates, and as well as the hangers. And we placed all these elements automatically from Grasshopper, choosing the length. They were like various, they were modular, so they were like large hangers and smaller hangers, obviously, because all the panels have different heights. So we were able to create like different groups of heights to use these different modules and then place them automatically into Archicad. And once in Archicad, we were able to create schedules and know exactly how many of each of these elements were used. So anyway, thank you so much. I'm gonna jump into, I don't know if we want to do a small break or we want to continue. I'm happy with both.
I think since we're running a bit late, we can continue, and we'll make a break when you finish and Carla takes over. Is that okay?
Okay, no, that's perfect.
Yeah.
Okay, so I just want to introduce you to the design problem. You can see on the screen one of the images of the space as it was designed. So we started with these very sketchy ideas and reference that the client loved, and obviously this is something that is quite difficult to do in Archicad. At the moment of the concept design phase, we had developed the model in Archicad, so you can see in the right side of the screen there is this sketch render that is showing all these butterflies. So that was coming from an Archicad model, very, very simple. Obviously, the butterflies were a Photoshop added effect, something quick like a sketch to express the idea. The client fell in love with this, and that was the direction for development. So we obviously had to find a way to create, and not only create, but also control the, because we're gonna, I mean, this is an item that is gonna be built, it's gonna be fabricated. So we needed to be very conscious about the number of items, the construction system, etc., etc. This is the space. So you can see here, the space is coming down from an upper floor to this kind of like a two-story or double height lobby, and we have those columns there in the middle. So what we wanted to do is to create this path. This is a Rhino screen cap, right? So the process that we followed was to create a marquee on the architectural model of Archicad, and this marquee was saved as Rhino file. Archicad creates really high quality Rhino files. So the file was, I will show you now in a minute, but we put the model, the model is coming from Archicad, the model of the room, and then we created this very, very simple 3D path in Rhino, and I'll show you now how the rest of the script was developed. If you want to follow, or if you want to create this on your own later on after the presentation, I recommend you to download these plugins. They are not 100% necessary, but I use them because they're really good and they really help to speed up certain things. So one is Elephant. Elephant is developed by a company called Front INC. The person that developed it's called Ramon van something. He's from Holland, and it's a really good plugin that helps embedding information into the Rhino element. So almost creating like a big model from Rhino, but also helps in other different workflows as well. It's really useful. Pufferfish is a super powerful plugin. I'm only using one or two components from Pufferfish that are actually very simple, but the Pufferfish plugin it's very useful. Both plugins are from Windows and Mac available. The last one obviously is to install the Archicad Live connection. So I don't know if maybe you can. I will probably share this presentation later, so you can get the address, the links from here. So let me jump into Rhino. Okay, so let me start with the Rhino screen. So this is the Rhino, the Archicad Rhino model. Okay, so this is the piece of model that was saved from Archicad. You can see that it's very it's coming like as a block, but obviously we can explode the block if we need. I'm not gonna do it because I don't need to modify the model, but the model is quite detailed, and I mean it's very detailed and it's quite clean. So if there is any Rhino user in the webinar, you can try and you will see that the geometries that are exported are very, very clean. So anyway, having this model as the environment, the only thing that we did is create this 3D path. How to do it? I mean, it was quite simple, but I can just repeat it. We use this command here that is the NURBS curve. And by using it here on the plan, what I did is just, you can see, you can just add control points, right? We can create a different curve. And then this curve here, we can go now into the perspective mode. Let me, for now, just, and you can see that I have, that this is placed in the XY plane. So the only thing that you need to do is locate it into the right plane and start playing around with this control point. So you can just start moving these points up and down as you need. So for example, this is the way that I created this path, right? You can start, we can just hide this for now. And then you will see that how easy to edit these points is. So we can play around, and even like if we don't want, we can delete some of these points to create like a more natural curvature. But you see that it's very easy in Rhino to play with this element. Okay, so once we have this in Rhino, that we can sort of compare to the model and understand, how are we doing in terms of height. For example, we can see here that, oh, we are inside the curve. We can use the thumbnail, this little 3 arrow. This is called the gumball, sorry, and it has like this. You can move the arrows to move in X and Y or Z, and then you can use as well these little planes here that will move in the XY plane, or if we rotate a little bit, also in the X or Y Z plane. Okay, so
Jorge,
this will help.
Just a quick one.
Yeah.
Could you make the line color another one? It's really hard to see.
No problem. No problem. No problem. Let me. Okay. Sorry. Let me go and the path line. Do it like just right, and I'm gonna just get these people out. Okay. So I think now it should be easier to see. Not really sure how to make it. I have to say that I'm not a very good Rhino user. So if there are Rhino users in the room, please don't laugh, because I'm only a very amateur. So I'm not sure if you can see better now. Perhaps I can use the Arctic view. Okay. So you can see now how the line is doing. Okay. So as I said, we can refine the design of this line. Anyway, once we have this, what I'm gonna do, let me go back to the wireframe because that can be quite heavy. So just gonna get this panel out, and I'm gonna open Grasshopper. How to do it? just type Grasshopper here in the command bar. And this is the script that I developed for the exercise. I have simplified quite a bit for this exercise. So most of the things that are related to fabrication they have been deleted just for clarity. But we will explain those processes in a later webinar. So anyway, the script starts obviously with the input of the lines. Okay, so just let me hide this, and we can try to use that one later on. So we have these two curves in here. Okay, I'm using a mode in Rhino Grasshopper, that is this one, that can hide. So this one will show all the geometry that we have created in Grasshopper. If we click this button here, it will only show whatever is selected. So it's very useful for debugging, or also to show only certain parts. So we started with these two lines. Okay, this will create the path that we want the lines to follow, and I'm just merging them together in order to have just like a group of these two lines to work together. Okay, you can see that the scripts goes in three different directions. The first one is this one here. I am dividing the curves in a 1.5 distance, okay? And I'm doing that because I want to find the perpendicular vector, the normal vector to the curve, okay? Why this? Because what I want to do, okay, let me just explain it quickly here. I want to create an offset to these curves, okay? An offset, but I want this offset to be natural. I don't want it to be like a strict, I don't know, 0.5 offset, all perfect. I want this offset to be a little bit, fluid. So what I'm doing is finding this vector that is perpendicular to the curves by using this frame, okay, the horizontal frames. So that is giving us, you can see, a bunch of planes in each of these points. So wherever there is a point, is creating a frame that is in the XY plane, okay? And this frame is aligned to the curve. So what I'm doing with these frames, okay, if I just get one of these frames just to see it, okay, so we can just see one of it. This frame has these two vectors, right? A frame is a plane, okay? It's just another way to call a plane. So we have the X and we have the Y vector, okay? And this Y vector happens to be the direction that I want to use. You can see that this Y vector is perpendicular into the both curves, because I have two curves, I have two planes, right? So what I'm doing is using that vector. So I want to find that vector. So in order to do that, I have to take these planes and deconstruct these planes. So you can just type deconstruct plane, okay? And I'm using this technique, which is just double clicking on the canvas and typing. So deconstruct plane. By the way, if you don't know about this or about the name of the specific node that you need, you can just find them, go into the bar here on top, and it's quite straightforward. So you have vectors, in this vector tab here, you have everything that is related to vectors, so planes and grids and vectors itself, curves for everything related to curves, surfaces. So it's quite straightforward, okay? So if you don't know the name, you can just try to figure it out. If you know the name, or at least some of the name, you can say plane, and then this plane will bring you to everything that has plane inside. So the search function is quite good. Okay, so I'm using this deconstruct plane to find the X, Y, Z, and origin of each of the planes. From this, I only need the Y, because we just figured out that the Y vector is the one that I need. How did I figure out? It's very simple. If you go to the top view, you can see here the you know, this little icon here on the bottom where you have Y and X, and then you have these two colors, green and red. So red is X and green is Y. So that's how I figure out which one I need, okay? So I took the Y and I just put it into a vector node, okay? An empty parameter vector, just to, you know, to keep it here. So this whole piece of code here, okay, that looks very, very complicated, but actually is not so complicated. It's just a repetition of this module here several times, okay? Actually, this one here. So what I'm doing with this, I'm taking this vector here, okay? And I'm using this function here that is called the graph mapper, okay? What the graph mapper is gonna do is gonna create a series of numbers from one number to the next, okay? And it's going to create a series of number within that range. Okay, let me explain in a practical example. So I want to move, okay, let me show you this. Let me show you this curve here, and let me show you the original curve, okay? So, and let's go to the top. So what I want to do, and I'm gonna just delete this curve here, and we're gonna play with only one curve. It's quite more comprehensive. So you see that I am moving all these points, okay, all the points that I had before in my curve. I'm moving them by a number. I'm creating this offset that is not constant, but it has this shape, okay? So what I'm moving these points from 0.2, so the minimum here is 0.2, and the maximum is 3 meters. So this is 0.2, and this is 3 meters here. So what I'm doing is, this represents the length of the curve, this direction, okay? And what I'm doing is dividing this edge here by the number of vectors that I have here. So I have 22 values. What I'm doing with this is called list length. So list length is giving me the number of elements in a list, 22. So I'm dividing this, I'm creating a range that is from 0 to 1, but divided by 21, okay? I'm doing like a little subtraction here using this expression editor. So I'm just subtracting one value. Why is that? Because if I want to have 22 numbers, I need to divide by 21 divisions, because I will have the first and the last and the 21 divisions. So that will give me 22. So I'm creating this range. So this is the length of the curve, okay? And these are these values, 0.2 and 0.3, okay? Actually, it's 0 to 1, but I'm remapping the values into a new domain that is this height. This, what it gives me, okay, is just a bunch of numbers. So I can just take a panel here and I can check what is this. And you can see that it's giving me a list of numbers, of 22 numbers that start in 0.2 and then start going up, going up, going up, exactly as this curve is doing, okay? So it's starting to move, and the maximum value is actually 1.9, which is roughly 2, okay? If we divide this in 3, okay, if this is 3 and that's 3 here, if we divide it in 3, so this is roughly the amount. Actually, if I move this curve, you see that the values just readapt, okay? You can see now this is higher actually, and then the value is higher. If I even take this node here and push it up, you see how the first number here is actually moving, because it was in the lowest value possible, that is 0.2, okay? And if I move this, if you see, if I move it up to the top, it will be 3. So this is what it's doing. Okay, this is one of the most difficult parts, guys. Don't bear with me. Okay, so once we have these numbers, okay, what I'm using these numbers for is to create a vector. Okay, so this is called amplitude. So this will take any vector, any given vector, and give them that vector a value of amplitude. Okay, so this is exactly what I need, because what I need is to have these these vectors that are going to move my points. They need to have specifically this proportion. Okay, so I'm taking the vector that I calculated first. If you remember, this y vector, okay, is this when you see these vectors vec, I'm just using these empty parameters just to organize the script. That is, it's just moving the same information from one to the other. Okay, so I'm taking this vector, I'm applying it a value of amplitude. So these vectors now have the module of the vector is this number. Okay, and I'm moving these points specifically to that distance there. Okay, you can see that. So after moving these points, I'm also applying a movement in the, so this was a movement in the y direction, and now I'm applying a movement in, okay, now it's exactly parallel in terms of height, but the movement is, it has this, this almost like sinuous or like this movement here. But in terms of height, it's exactly the same heights. What I want to do is move it as well in the z value. Okay, so I'm just taking these points and I'm moving them exactly with the same technique. I'm moving them from 0 to 1.5. Okay, so if I show the new curve in here, okay, I'm just going to preview it. You see that the new curve now, actually it's almost the same, but I can, I can start playing with, okay, with these numbers, and so now it won't be any more similar in height as the other, but I'm also deforming the height of this. Okay, I don't want to go too crazy because this might later on affect, but this is the idea. So I'm doing this not only in one side, but in both sides. So this is exactly what I'm doing, taking the points, moving them here, and then moving them up and down. And then taking the same points, moving them to the other direction, and moving them up and down. So that's why I have this one here, okay? So this one here moves the point in one direction, this one here in the other direction. You can see it here, okay? In both sides of the, and then these guys are going up and down. Okay, so it's very simple. It's just very repetitive. It looks quite complex, but it's very simple. Okay, then once I have the two curves, okay, I have these two curves, I just join them to get, I created the lines on both ends. How did I do that? I just use a component called endpoints that will give me these points on the end, and then just connecting them with a line, and then just join together this. Okay, why is that? Because I want to use this area here to select points that are going to be in a larger grid. Okay, so that I'm projecting it to the, to a flat plane, and I'm just using this as this is called union, okay? And this was useful when I had two curves, but because I just deleted one, I don't need this anymore because I have only one region. When I had two, then I will need to create like this union of these two shapes, okay? Not anymore. Okay, so I have the area that I want to create the scatter of points, okay? That this area obviously depends on my line. If I go and show the line, okay, if I show the line, the original line, okay, I'm gonna just show selected. Okay, I just want to select this line here. Okay, if I move this line now, everything should adapt accordingly. So if I move the original line a little bit, I'm not sure if it's visible enough, but the script should, sorry, let me just, I think set one curve. This one here, okay. You see now, it was not connected, but if I move the line, the script will create this accordingly, right? So everything now is connected to that original line. Cool. So this is like the first part of the script. You see, we're halfway through. The second part that I'm gonna start is to create a grid. Okay. Why I want to create a grid? Because I don't want the points here to be completely random. So because of the fact that we need to build them, and then we need to locate them and give a set out for each of these points, what I'm gonna do is, instead of creating a random location of the points, that will be a very, very easy way to do it in Grasshopper. But instead of doing that, what I'm gonna do is I'm gonna create a grid of points, and this grid of points, I'm going to select the points that I need, which are inside this area here. And later on, I'm going to create this. I'm going to project these points into the curve. Okay. So, okay. So in order to create the grid, you will see some elements here that actually I'm not using anymore because they were important for the fabrication part. But don't worry, because I will explain this in the next webinar. Okay, so we're gonna start with this point. Okay, this point is giving me the you can see it here. So this point is giving me the height of the floor finish of this element. I could also have brought from Archicad. I didn't do it that way, but we could have as well brought from Archicad the story. I'm going to story plane. Okay. So story plane will give you the story settings. So it will give you a plane. So if let's cross fingers and connect Archicad. Okay, bear with me if something goes wrong, because just streaming all these, it just makes the connection a little bit more unstable.
Yeah.
So
it uses a lot of the graphics card.
Yeah, so I'm gonna try. So what I'm gonna do now, okay, this is reading the Archicad story planes. Okay, so I could say, okay, I just want to have my B1. Okay, that's the name of the story, and what that is giving me. Okay, and I'm going to connect this into a plane. Okay. Okay, give me a second. I'm just okay. So 1 second. Okay, I'm gonna show you in a different way, but the idea is that this will give you a plane. Okay, and this plane, we can just use it for now it's not connected anymore, but you see now it works well. But this plane will be similar to this other workflow that I use. Okay, so what the workflow that I use is just find a point here, and you project this point into Okay, this point here, excuse me, this point here is my set out point, okay? This point here. So what I'm doing is moving that point into the right location. You can see here. So this will be the plane where all my my ceiling will be, and it's 3.5 meters from this finished floor plane B1. Okay, so I can control this parametrically as well. Okay, so I had it at 3.5 for a reason, actually for avoid the MEP, but I just have it here. But if we need to move it, I can move it from here. Okay, and I'm just creating a circle there so I can see it better. Okay, and from this point here, I want to create a grid of 1.5 meters. Okay, so I'm creating this grid here. Okay, and this grid is based on the, okay, so I have this, this is my region here, and this point, okay, both points are giving me this region, okay, this box. It's called a bounding box. Yeah. And what I'm doing now is measuring these two sides of the box. So I want to know what is the length of these two sides, okay? So I'm connecting this to a edge component, okay? Brep edge, and that gives me the naked edges. Naked means the external edges, edges that are not connected to anything else. In this case, I have 4, so these 4, and I'm creating. I'm taking these 4 lines and measuring the length. Okay, I'm using this component called length, and this will measure the length of a curve. So I have these 4 values here. Okay, you can see if I add a panel here, you will see these 4 values. But actually, and it makes sense, they are this 2, they are same 2 to 2. Okay, so these 2 are the same, these 2 are the same. So I only need 2. So I'm connecting this component that is called set, okay, create set, and this create set component is very interesting. It scans through the list of numbers and it gives you the number, the elements that are unique, okay? So you can see here, it gives you 2 things. It gives you the elements that are unique on a list and the location of these elements, okay? You can see here. So it's telling you that there is one element that the component calls 0, that is 8.7, okay? And you see that 0, it's located in these 2 points, okay? Here and here. And the other component, 1, that is in this position, okay? If we had 3 that are the same, we will have 0.012, etc. Okay? Anyway, I only need these 2 ones that are different, because what I want to do is I want to, first of all, I want to round them first, okay? I don't want this number, 0.77 something. I just want to have a round number, okay? So what I'm doing is taking this division, okay? And this division is taking these numbers here divided by my panel grid, 1.5, okay? Why is that? It's very simple. What I want to do is take the square, okay, and take this and divide it by a number of panels that is related to the length of the how do you say, of the curve, right? And the area that I want to cover. So I don't want to I don't want to have more panels here or less panels, because they won't cover all the area that I want. So I'm taking all that, creating the box, and then learning about this length, dividing it by the panel size, and that will give me a quite odd number, right? If I look at these numbers here, it's 5.84. This is not a number of panels. This is an odd number. So I need a round number. So I apply this round component, and this is giving me the nearest, the floor, so the one below, or the one on the ceiling value. I want the ceiling value because I want to make sure that I cover all the area, okay? So that is giving me two numbers. One is 16 and the other one is 6. So I'm gonna have 6 panels of 1.5 and 16 panels of 1.5, okay? This is my grid, this is my module, okay? This will be important later on for fabrication, okay? What I'm doing now here is taking this grid. This grid is giving me a lot of squares, okay? It's giving me exactly 96 squares. I don't want, at the moment, at this point, I don't want all these squares. I just want to make sure that this is modular. So I'm joining together, again, the same thing, the box, and I am subdividing this surface, okay? Subdividing by a number. So 49 and 99. Why is this? Because I want to have 100 points by 50 points, okay? So I'm dividing by one less, similar to what we did before, okay? I could have related this as well to the module, but this was way faster, and I can also control this with a slider if I want. So I can create a slider from 0 to 100 and then go to 99 and connect. So this will also work, okay? You can see how if I go lower, then you will see less and less division. So this could be parametric as well, okay? At the moment, because I know I don't want to move it, I'm gonna just keep it with a panel, okay? So now I have all my points here. They are all together. There are a bunch of points, and what I need to do, okay, I need to do two things with these points, okay? The first thing I need to do is I need to use them for my, I need to find the ones that are inside my area. This is the first thing. So this is why this is branching out, okay? The other thing that I need to do, and this will be very important for Carlo later, I need to create a grid, okay? I need this grid of lines. And this is gonna be important later on for labeling and to create an ID system, okay? So how I do this is very simple. I have this subdivision here of points, and this is giving me, okay, 5,000 points divided in 100 values, okay? I don't understand that very well, but I can use this component is called point list, okay? And this point list, what it's giving me is, let me make this number larger so you can see. Oops, too large. 1 perhaps, too much, 0.5 maybe, 0.3. Sorry, because this is the size of the number, okay? So you can see it's even too large, but you can see what is the division. So you see that all these numbers here go from 0 to, if I go to the other side, they will be 99, okay? From 0 to 99, those are 100 points, okay? Because 0 counts as well. So what I'm learning about this is that this component is grouping the points in these lines here, right? In these vertical lines, okay? So something that I have learned is that if I take the first and the last point of these lines, I'm going to be able to create a single line, okay? And this is what I did here. I am selecting using this component that is called list item, okay? You can just type list item. This list item will take any list, okay? And by default, it has a hard scripted the number 0. So by default, it's gonna take the first element in a list, okay? In this case, we have several lists. We have 50 lists. So each of these lines is considered a list, okay? If I look here at the information, we can see that we have 50, okay? You see like all the groups go from the top to the bottom, from 0 to 49. The list, and each of the lists have a number of 100 elements. So each of these guys are one list. So by taking this item and having here the number 0, okay, I have a panel and I just type 0. By having 0, this will be the item that I choose. If I have -1, okay, and this is tricky, but it's and this is a notation that is that repeats everywhere in Grasshopper. -1 will refer to the last item. So imagine this list to be a circle. If you start from the beginning, you will be 1, 2, 3, 4, 5 until 100. But if you start from the opposite direction, your last item will be the -1. Okay, so this is the notation that we use in the list management and list operations. So if I type here -1 and also 0, okay, nothing happens, and this is because I just need to make this a multi-line data. Otherwise, it doesn't know there are more than one element. So now I have 2, and this component, it's able to select the 2 of them at the same time. Okay. Also, alternatively, I can do one more thing. Okay, let me just keep that there. Alternatively, what I can do is, let me disconnect this from here. You can just go here, disconnect. Okay, what I can do is I can keep the 0 here. And if I go closer, I will find this element. So if I click in here, it will add 1 in that direction. So I have the element that I want, that at this point is the first one, and +1. Okay, now I have the first and the second. And I can remove it as well. But if I go plus in the other direction, I will go and have the -1 as well. So this is quite handy because you can add as many as you want. You see, I can just keep adding, and that will give me as many elements as I need. Now I need only these 2. Okay, and this is what I have. This is what I have here. Let me just disable these components. Okay, so by having these elements, I can just do a line. Okay, this is a component that is called line. I just type line here, and line will ask me for a start point and an end point. Okay, so this is what I'm doing. Starting point is the 0, just to keep some consistency as well. So 0 goes to A, -1 goes to B, and I have all these grids here. Okay. Okay, I need to do the other one, and this is just one step more. Okay, so what I need to do here, I have this, okay, these 50 groups of 100 elements. This in algebra is called a matrix. Okay, it's like the movie, the Matrix. So this matrix of elements, you have to imagine them as in a grid, right? Of like a you know, like a square grid, where you can divide these. Okay, just like a very simple matrix will be this one. Okay, this will be 2 groups of 3 or three groups of 2, right? Depending on how you're looking at this matrix. Okay, so this is what the property that we are using of this matrix is sorry, the operation is flipping. So by flipping this matrix, what I'm doing is taking all the columns, and the columns will become the rows and vice versa. So now by using this flip matrix, that you can just type flip and you can find this flip matrix, this one will rotate the structure of the information, and it will give you 100 groups of 50 elements. And that is exactly what we need. Because if I look at if I do the same thing, I choose the first and the last, I will see that that's happening in the other direction. I do exactly the same, right? And I'm just merging these two using this merge component. So I have both the vertical and the horizontal in the same group. And this is, I'm just sending this to Archicad, okay? And this is the simplest thing. I'm sending this as a morph, okay? I will do all the sending later on. But just to explain a little bit the setting, I'm using the morph. I'm using the morph curve, not the morph solid, okay? And I'm just attaching to the morph the curves in 3D. And I'm using the morph setting material that you can find here, okay, in the morph settings, this one here. And what I'm doing is just adding a building material and a layer, okay? As Marcelo explained before, you could also create a favorite for these morphs and just attach the favorite, which would be very convenient because it's only one component, okay? Very importantly, I'm using this toggle, okay, Boolean toggle. Actually, I think this is not coming out of the box. The one that it's coming out of the box is called
Boolean toggle, right?
Just Boolean toggle. The only difference is that this one, every time that you close the file, goes back to false automatically. It's one plugin that I found online. This one is you have to do it manually. Okay. I will also give you the. I forgot to put this on the plugins. Okay. So this is the grids. And then we're almost done, actually. It's a very few things that we need to do, okay? All this part here, okay, this is the Elefront baking system. So this is very similar to what the Archicad. If you look at it, it actually looks very similar. So it's what it does, it just bakes this information into Rhino with some properties. So you can add a name, you can add some information. I'm not using any information, but I'm just creating a new layer, adding a color. So it's actually very, very similar to how the Archicad works. And what this does is I can have the latest, the most updated geometry in Rhino as well. And if I want, I can add some user attribute information here. That this I will explain in the next in the fabrication part, because it was very, very important. But for now, for the design part, it's not so important. I just have it here because at any point when I do any modification, I like to have as well. I just click on the activate, and that will overwrite the old geometry. So it will change the geometry in Rhino as well. So it's similar to what Archicad does, okay? Anyway, so we can check as well in Rhino. I can just get the top grid and show it, okay? You see? Actually, it seems that I have two sets of grids. So let me just come 1 second here. Just select everything in the layer, delete those elements. Okay, delete those elements, and I can just simply come here, activate again, and you see that now I have it. Okay, I think I deleted the swatch button, so you can just color your elements if you want as well. So I'm just gonna bring a color. This is similar to the building material thing, if you like, but for Rhino. And then, you see that now I have changed the element in Rhino. If I wanted to create a different geometry, like a different modulation, I will be able to just do it and click on activate, and it will just remove whatever is not necessary and replace the geometry, okay? It's very, very similar to Archicad. Okay, so we have that. This was very, very important. Now, now what we want to do is, okay, we want to, so we have our curves here, okay? So we're kind of like going back in time. And what I want to do is project those curves into this surface here. Sorry, I don't know which surface we're talking about. Oh, here. Yeah. So I'm just projecting this geometry and making sure that they are in the same level as the grid. So this is just for how do you say, for precaution. Let me turn off the top grid because it will be easier to see. Okay, so we have the grid there. So sorry, I'm just projecting this to be sure that I am in the right plane. Okay, precaution. And then what I'm doing is I have the grid of points that we had before. Okay, this is the same. Actually, this is redundant. I don't need this one. And what I'm doing is, you see that I still have the structure that we discussed before, this matrix structure inside the points, and I don't need this anymore. So I'm gonna use component here called flatten. Okay, this part of Grasshopper is probably the most difficult. So if you look at the structure of points from here, okay, actually let me use this data viewer. Okay, so this data viewer, it's going to help me to visualize the data. So here you can see that in this component here, I have these 50 branches of information with 100 elements. When I use the flatten, or when I right click and flatten here, is the same thing. When I use the flatten, what I do, okay, is I break all that structure of information and it just collapse all the data into one list of 5,000 elements. So here we have like groups of 100 elements. If you remember, they were grouped in these lines. And by flatten them, I don't have this structure anymore. The points are the same, but they are not organized in any way, okay? There's no structure. So why I'm doing that? Just to avoid problems, okay? What I'm doing now is taking all these points and checking if they are inside this line. And I'm using this component that is called point in curve, okay? So if you type point in curve, okay, point in curve. So I have one curve. You know, I can just come here. This is in the curve, tab, in the analysis, under the analysis area, and this is point in curve there. Okay. So what I'm connecting here is very simple. I have the list of points and the curve. It's very, very simple, and that is giving me, okay, that is giving me this result, okay? It's giving me zeros, or it's giving me ones, or sorry, 0, 1, or 2. What does it mean? If you hover your mouse here, you can see that you can see under the relationship name, it has point region relationship. 0 means outside, 1 means coincident, and 2 means inside. So I'm looking for all the points that have this 0 relationship. Sorry, that have this either 1 or 2 relationship. Okay, so I'm gonna use this component that is called cal, sorry, and this cal component is going to eliminate, okay, this call pattern. let me show you where it is. It sits there under the sets, okay, and sequence, and you can find here several cal. So this one will ask me for specific index numbers, which I don't know. This one will ask me for like a pattern that is repetitive, and this cal pattern is gonna ask me for a 0/1 pattern, and this pattern I have created already by checking the relationship. Everything that is 0 in here, it's going to be cal, which means eliminate, okay? It will remove. So in here, I am connecting the list of points, okay? In here, I am connecting the relationship. So all these 0s, 1s, and 2, and everything that is everything that is either 1 or 2 means that it's either inside or on top of the line. Everything that is 0, it will be deleted from the list. So now I have the list of points that I need from my grid, okay? And now this part is quite straightforward and quite fun. I'm using a component called random reduce, and this component is literally reducing the points, eliminating, but in a random manner, okay? What it's asking me here, it's asking me the list, it's asking me the reduction, and it's asking me the, this is called the seed for the random, for creating the randomness, okay? But why I am doing this complicated thing, this is just because I want to be able to control the number of elements that I want to keep, not the ones that I want to reduce. So I want to keep 500 elements, okay? And I have 1,529 elements. So what I'm doing here is measuring the amount of elements of points in the list. So therefore 1,529, and I'm creating a simple subtraction just to know in absolute how many elements do I need to eliminate. Okay, so by controlling this number, I can control how many I keep rather than how many I reduce. Okay. Anyway, if you look at the difference, so these are all the points on the grid. These are the ones that I am going to keep. 500 elements. I want to be able to control that quite precisely, because this is going to later on become like a light bulb, or like some sort of valuable piece. So I want to make sure that I'm able to quantify, that I'm able to also control the cost for that. And once I have that, I have my top points, and I am going to, so all this part here is important for the fabrication. I'm just gonna quickly run through it, but not gonna go in detail, okay? So now that I have the points on top, I want to project them into the height of the curve. And that sounds easy, but it's not so simple, okay? Why is that? Because we need to, if we want to project this, we need to have like a surface to project to, okay? And this, honestly, because I'm not very good in Rhino, this took me a while to figure out how to do it. So how did I do it? Actually, at the end, quite simple. I have the curve, the original curve, okay? And this original curve, I just use this patch component, and that patch component is creating a surface that is actually topologically is the same as the curve. So the curve is contained in that surface, okay? If we had more than one curve, this becomes more complicated, but actually this is very handy, okay? So it's a very simple component actually. And what I'm doing now is, okay, this is the baking system that I told you about. And what I'm doing now is that surface, okay? I'm just projecting the points okay? These points I am projecting. So I'm using a component that is called project point. Again, this is under the vector and project point, but you can just type it, okay? Project, and you have all the projections. This one is very straightforward because I have points and I have a surface, so I just need that. And I need to give a direction. So the software or the component is not gonna know if it needs to go up or down or sideways. It doesn't know. So I need to provide a direction. So what I'm doing is, because I am assuming that these points are the top points, right? They are in the top. So I need to project downwards. So I'm using the vector set. So if I type set here, it will give me the unit set. This is a vector, one of the standard vectors. And the only thing I'm doing is reversing the vector. So I'm using this reverse component to point the vector down instead of up, okay? Okay, quite simple. I just connect the surface to project into, and I project it, and it looks amazing already, okay? Just a couple of concerns. Because the surface was created without a lot of control, and also because the projection is downwards, but it might happen, could have happened actually, that, let me check this, could have happened that some of these points actually, in relationship with the surface, I am not sure, but maybe some of these points actually will need to project upwards instead of downwards. So these points there, they're gonna give me a little error, okay? They're gonna give me a little error. Actually, you know what? I have 77 errors. So that's why I figured out this after a few rounds of testing. And I have this, so this has 500 components, but you can see that in the bottom of that list, I have a null. Null means that an empty or invalid element in the list. So what I'm doing is just checking the nulls, okay? Like connecting this null item, and this is just giving me the number of items here that I have in this list, 77, okay? I can use this dispatch command. Using this relationship, everything that is true, it will be going to the A list, so 77 values that are invalid, and the rest are going to B. So these B are the points that are actually valid for projection, okay? And then I'm using at the same, and that, with that I'm cleaning the top points, okay? Because I'm gonna create lines from point A to point B, I need to have the same amount of elements. So I have to clean both lists. I have to clean the projected list, but I have to clean also the top point because I need the same amount of elements, okay? So that's why I'm cleaning both. I'm dispatching all the errors in one side, and I'm keeping the 423 elements that are valid. And in here, from the project, I'm cleaning, okay? This component is called clean. I'm cleaning every element that there is either nulls or invalid or empty, okay? So I don't have any of these, invalid or empty, but I have 77 nulls. Anyway, after that, I have two sets of points, okay? The point on the top and the point on the bottom. And what I'm doing now is actually not necessary for the design part, but I thought it could be interesting to share. What I'm doing is measuring the distance between these two sets of points, okay? And that's gonna give me quite a set of odd numbers, okay? You're gonna see here, so I have 3.792454, etc., etc. So nobody's gonna be able to customize the length of the cable using these measurements, okay? So what I want to do is take this dimension. I want to round them up or down, okay, to a factor. In this case, I want them to be round to a factor of 0.1 meters. So every 10 centimeters, okay? And they're gonna be round to the ceiling, so to the higher value. So this one will be round to 3.8. This will be 1.4 and 4 meters, etc. So that actually, if you take a look here, okay. Oh, sorry about this. If I copy this list here and I take this set of numbers, you can see, okay, that this is a much more, much nicer set of numbers to actually give for a construction or a fabricator. It doesn't make sense, this one. So this was interesting. Anyway, so using this rounding, I corrected the move. So now these points are moved the exact, this exact amount, not this one, okay? And I created these lines to connect both sets of points. And the only thing that I did here, it's eliminate points that are smaller than certain value, okay? So this, again, is more for fabrication, but I just decided that everything that is smaller than 25 centimeters, it doesn't make sense to have because they're not gonna be visible or because I don't want. I can obviously move this threshold as I need, and I'm cleaning that. I'm just creating the cable, and the cable is giving me 2 sets of points, and we have ended the script. So at this point, the only thing that we need to do is connect this into our object. And I'm gonna super quickly explain to you something about our object, and we're gonna send it. And that's it, we're done. Okay, so for our object, okay, you can see here, I have already the object imported, but the object that we use, okay, the object that Carlo created this morning, okay, is this LED light. Okay, I'm just gonna place it here so we can see it. Okay, I think, sorry, I think it's just, yeah, going down. Anyway, I'm just gonna pull it up a little bit. So the light component is correct, but it's just one thing missing, okay? I want to be able to control this height from Grasshopper, okay? So what is the problem if I wanna do that? And I need to connect now Grasshopper, so let's hope for the best. Okay, so I'll go to Rhino. Now it's lagging a little bit.
Yeah, it's trying to run.
It's trying to connect.
Yeah.
Okay, so the problem, or the, not the problem, but the fact is that elements that are coming from from Archicad into Grasshopper, you're able to place them, so you can select library elements, but all the GDL parameters are locked. Okay, so they're locked. So to avoid problems with the elements, honestly, I don't know why they were blocked. In the first version of the Grasshopper connection, they were not, but then maybe there were some problems, I don't know, and they came locked.
I think it's to prevent like users from editing them.
Yeah.
In case you don't know where they're coming from.
Maybe. So, okay, this might be a challenge until it connects. So I'm just gonna explain to you inside the Archicad. Okay, so there is one thing that you need to know about the Grasshopper. If you want to control this height, this height is a parameter that was set in Paramo. If you guys remember from this morning, Carlo created this cable length as one parameter. So if we open the object, so if we go to element, libraries and objects, an open object, okay, made with love with Paramo by Carlo. Okay, so the parameters are here, and I believe that the parameter we want to cable surface, no, cable, maybe it's one of these bottom level, top level. I think, yeah, I think it's one of these variables that we want to use as the height of the cable. Okay, or perhaps it's, no, it's this one, height. This height is the height that we want to be able to control. Okay, problem is that in the Grasshopper side, that won't be possible. Let me try again. I think it just got stuck. Okay, so those parameters won't be able to be edited by Grasshopper unless you do one thing. This one thing is, and I'm going to show you because I don't remember by heart, but I will show you in this other element here. Okay, this one here. Okay, sorry. Okay, so in this one, if I open the object, you can see that I have, sorry, I think I used the same one. Sorry. I just want to change the object for this one LED light. Okay, and now I can open the object. You need to add this one parameter here. So how you do that, you just create a new parameter, okay, and then you call it param control by Grasshopper. This is the name of the parameter, okay? Maybe it will give me an error or something because it exists already. It needs to be a Boolean type, okay? So a yes or no. And if we want to enable the control of the parameters, we need to keep it on, okay? So this is the key for controlling your parameters from Grasshopper, okay? I'm gonna delete and not save. So by doing this, the elements become, let me see if this helps actually. Taking the shadows off or everything, I don't know. So, sorry about this. Okay, how are we doing with the time? We are right on time, no?
We are right on time, yeah.
Okay, so
I think it's okay if you need to take 5 or 10 minutes.
Yeah, no, I just wanted to send the object again to Archicad, although the rest of the things are already being explained, but maybe I need to restart Rhino, guys.
Yeah, so I think what we could do is instead of taking the break, so now would be the time for the break.
Yeah.
So we take the 15-minute break now, and you make it run, because I can imagine that script is placing so many elements that will take a few minutes. So you make it run, and then we continue.
Perfect. And it'll take me 1 or 2 minutes max to send the elements to, so then we can continue with Carlo. Okay.
Yeah.
I will just restart this.
Yeah. So let's make the break for now, and yeah, we'll continue with in 15 minutes time. So Carlo, Jorge will steal a couple of minutes from you or a few minutes from you to show the result.
Sure, no problem. Yeah.
And then we continue.
Sorry.
It's okay. It's okay.
Mine is very fast. My next presentation will be very fast.
Okay. Okay.
Yeah. So
So 4:15 then. We'll do a quick break now. Okay, guys.
Okay.
Catch
See
up
you.
soon. Thank you. Great stuff, Jorge.
Thanks.
Yeah, really great stuff. Thank you.
I'm not sure if there were questions, but maybe we can.
There were a few, but we try to answer meanwhile. Mostly people want to understand how to learn all this this kind of scripts. Like how do you get there? So Eugenio already explained that it takes a lot of dedication and a lot of long time trying to understand scripts to do what you want. Basically, I normally like to compare a little bit with like, well, if you want to be a expert in rendering, you need to really investigate a lot, see what are the resources that are out there, what are the plugins that you should use, and probably even go into some forums, some Facebook groups, some LinkedIn groups, and then at the end of the day, everyone helps a little bit. Everyone. So we had also other people asking for the scripts if we can share the script. So we'll see everything that can be shared, then we will find a way to do it.
Okay, just to add to your answer to how you get there, at least my experience, I managed to found, so the community of Rhino Grasshopper is very generous, okay? And there's a lot of material out there for learning, and not only for learning, but also they give away a lot of their scripts. The Food for Rhino forum, it's very, very active. And people there is very, again, very generous to, if you post a question within a few hours or a day or two, there's somebody will reply to you. They will even take your script and try to fix it. So if you don't have a friend or somebody like that that can help you with the process of learning, just don't be afraid of going to a forum, ask for some advice. And also Googling, because I just found out when I was learning that there is the same problem that I had, like 100,000 people had it before.
Yeah.
How to deal with this, how to deal with that. So it's very stupid, but just type in Google, Grasshopper, how to divide a curve, for example. And then you see all these links to the different Rhino forums, in Food for Rhino, I think, or Rhino forum. And a lot of people are answering these questions and giving away examples, like I did it in this way, and then they give away the script. So you can just literally take the script, open it, understand it, and copy and paste it in your own script. So that helped me a lot. And also watching YouTube videos. During like 3 or 4 months, I didn't even open Grasshopper, but I was watching videos, and that helped me to understand the lingo, the terms, where things are, just watching videos, just not without doing anything else.
Yeah, so it doesn't come without investment, right? You have to really look into it, and
but if you are curious, there's really, I mean, it's a thing that is not impossible. You know,
I normally say that, I'm so lazy to work that I rather spend time investigating so that I can work as lazy as possible. And this is a little bit of that. So you're spending like 4 hours to look at something that it will take you 4 minutes to do it, instead of doing that thing in 4 hours.
Yeah.
Right?
More or less. Exactly.
Yeah.
So,
okay.
That's my take.
Yeah, it's great stuff. I think that, well, that's what people like to understand, how to get there. So we had someone asking for the forum name, that what you were mentioning.
Yeah, let me maybe share again the screen, and I can show.
Yeah, I normally just watch YouTube videos about it. Like I type something that I think that is what I want to learn.
So guys, if you come here, Google and search literally Grasshopper, you see sorry, just lost it. Grasshopper, you see this green with the grasshopper here. So the forum name is called grasshopper3d.com forum. So anything that you start with grasshopper, how to, for example, flatten a list. I don't know how. You see, like this grasshopper 3D forum, there are like hundreds of different replies. So you can just come here and somebody's asking, okay, I have this problem, I don't know how to do this. And you see how a lot of people, even this guy, David Rutten, this is the guy that developed Grasshopper. This is the one and only. So he wrote all the Grasshopper. So this guy, it's in the forums, just replying any loser like me.
Amazing.
You know? So they are, and they're giving away, not in this specific one, but they're giving away the scripts as examples. They, you know, they teach you how to do it. So don't be afraid. This is the forum. And as Marcelo said, just go to YouTube. Maybe, I mean, if I have time in the next week or so, maybe I will post some of my favorite. You know that we have a blog. So I think somewhere here I have a Grasshopper set of tutorials that I might even put it on a list in. I don't know how to find these guys in. Anyway, but if you search for Grasshopper tutorial, this guy is great. This is Parametric house or something like that. So there are a lot of tutorials, you know, like maybe 20 minutes or 30 minutes tutorial, 15 minutes that explain to you how to do one thing.
You can just look at like one image and you want to understand how that is generated.
Yeah.
And it's quite interesting.
Right? This guy is great. I follow this guy. And it has a lot of, obviously some of them are not for free. Then maybe the more complex, but there is a lot of free stuff, So if I have time, I will maybe really spend some time. I have I don't know, you see like tutorials and Grasshopper tutorials. I have a bunch of places that I go sometimes. And so maybe I will, if I have time, I will create this.
You know, that it could even be like a good article for your blog, you know, like resources, where do we get things?
Yeah, exactly.
Probably you could show your blog where you normally share this kind of stuff.
Sure. So we have this, if you go to our site, we are enzyme.com, then you can go to blog. Now we are redoing the whole site, so maybe it looks a bit funky, but the content is here. So we have a lot of, for example, about Grasshopper, like somewhere here, more about Grasshopper. So for example, this one here. And you can find stuff that we've been explaining how to do, links to some videos, or we did a few videos as well sometimes ourselves. So about sustainable design, so how to use Grasshopper in so you can also just go in our blog and take a look.
Yeah, great stuff.
Okay. Okay, maybe I don't know if Vignes wants to request control of my screen.
Yeah. Probably, I don't know, probably they click somewhere.
Okay. Sorry, unless you explain me why, I won't do it. Okay, so yeah, that's the thing. So
okay, do you want to take this like 3-minute break and probably go to washroom or something? So we will resume at 4:15.
Okay.
So that you could show the result.
I'm preparing. Yeah.
Okay. So meanwhile, I'll take over and share.
Perfect.
My screen here. then you can take it back.
Cool.
So, okay, everyone. So the break, let's resume. I hope you had a nice break now. So Jorge, if you're ready to show, or if
Yeah.
if the
Yeah.
script manager just take control of the screen, or take control of the screen sharing.
Okay, let's try. Don't be angry if.
Don't worry.
Okay. Now, sorry, but my computer. I mean, I'm using a MacBook Pro, so a laptop to do all this, and it's true that whenever you are doing all the screen sharing and this and that,
yeah,
it suffers a bit. So okay, I'm now in Windows, so I'm connecting to another computer in the office. Let's see how this works. So I have Grasshopper, sorry, the Archicad on. I have Rhino and Grasshopper in here as well. So the script that we had before. And what we're gonna do is connect first to Grasshopper. I'm going to delete all these elements, okay? So, oops, sorry. Where am I? Yeah. Control is not command, sorry.
Yeah,
I get it.
Now you have to change the mindset.
Okay, yeah. So I think I have this saved. Okay, I'm just gonna delete all these guys. Delete the grids as well. And then let's start from the scratch. So we have the empty space. Seems that it's running. So let's go back here. Everything is here. So maybe I just explain you briefly what I wanted to show you before. So once you have the object, okay, in Archicad you can have an object, right? Let me create a new object. Okay, you can use an object from the library, or you can create a new object. So how you do that? You just right click here in the black area of the node, and then you can choose. By default, you're going to create a new library part. So anything that you model here in Rhino Grasshopper, you will be able to send it as a library part. But you can also use existing library parts. So what that does is that this gives you access. Let's see in here. Oh, it's asking me the login name, I think. Okay, so it's just I have some Bim Cloud Libraries here. So anyway, what it will do is it will allow you to access the Archicad library, and it's gonna scan through your library objects. Okay, and I have here, you see BCA library. This is the one that we're using, and this is the LED light that we created this morning. And you see that I have that all these are grayed out, so I don't have access to any of this. I can still select it, okay? So I will select this, and let's do something. Let's send these objects first. So I can just send this first. What is the problem? That I don't have I don't have control of the height. So all of them, I'm not sure if they're very, very visible. I don't think so. Let me unlock these elements and change the color, change the lights, okay? and I'm just going to color them red or something, so it's easy to see. Okay, cadmium orange. Okay, so you see that all the elements are the same height, and this is not what I want. Okay, what I want is control the height depending to the distance that we set out in in respect of the surface. So this is not what I need. Okay, I'm going to just delete all these elements so they don't bother me later. So what I want is to be able to control, okay, I'm going to just disable this. So I want to be able to control the height. And if I go here into the select Archicad library, this is the one that I'm using. You see that all these now are available to, I can just click here. I could just click here and here to enable these elements into the node. If I click OK, see that these elements here, they will be available. I can just select as many as I need. I don't need these guys here. I don't want to mess with them. I just need the height. Okay. I could also control, for example, the height of the bulb or the surface or the cable surface, whatever. But I just need the height at this point. Okay. And the height is going to be informed by the length of these curves. So I'm just measuring these curves, taking the length of that. This is a number, and this is entering as a number into the height value. Okay, and then I need to give an anchor point, and this is important because every object has an anchor point, and this anchor point will be the top. And this really depends on how you model your elements, right? So I'm just going to click on true. I'm going to send these elements. If I go to Archicad, right, this is exactly what I need. So let me just, again, I'm going to override this for like a yellow or something more visible, right? And this is exactly what I needed. So all these are coming to the right place. Okay. The only problem of these elements at this point, and by doing this, I'm introducing the next exercise, is that I have no control whatsoever about the ID, the name. I have no idea how these are. You see, they are all called Object 7. I don't know how these are named. I don't know how I'm gonna be able to schedule them and properly. Okay, so I have two options. Okay, one is the one that I did before, is create a logic here that can easily duplicate the size of this script in order to make a parametric logic to name and label, and that's actually very interesting. The other thing that I can do is I can send these grids here that I'm sending, these morphs, okay? You see now, these are super quick to send, and because now we have access to this Python, the Python scripts in Archicad, now we can use these elements here to control the ID, naming, and some properties of this element. So instead of creating a very complex logic in Grasshopper, okay, that it might come handy in other, maybe in other instances, what we're gonna do is use this for the, with Python for automating the labeling and the naming system. Okay, I think I'm done. Sorry about this interruption. But
I think it's okay. At least we get a closure to it.
okay. Okay, so I'm gonna give back to Carlo. Okay, I don't know how to. Let me just.
I think you will just request you will just ask to share the screen, and then you will be kicked out. So thank you very much, Jorge.
No worries.
This was like amazing presentation. You really went through all the steps. We could see how your mind was thinking when coming out with this script. Again, I would like to emphasize that the idea of this event is that it's going to be it's being fully recorded, so
Yeah.
you guys can see it later on YouTube. I will showcase later again where is the link for you guys to go and find it, and we'll still discuss and see how we can share the materials and we make them reach to you guys. Okay,
Thank you.
thanks again. So Carlo, the stage is yours. Go ahead, Fred.
Yeah, sure.
Go,
Thank
Carlo,
you.
go.
Yeah, thank you, Jorge, for giving me a problem. Now, how am I going to automate all the thousand lines you have in the
I
object?
know.
Okay, so luckily we have this Python, and with the help of my colleague Ralph and Chidam, so we plan and manage to find a way to automate that thing. Okay, so before I start the automation, okay, so just for your information, we have this Archicad release 24 libraries for Python. The version is 2310 commands, so you can actually download this one in the link showed in the slides. Okay, so it's properly documented, but of course, still under testing. There's still some functions that is missing, like for example, placing the object, just like Gerald is asking earlier, I think. Then, but of course, all the basics is there. All the documentation is inside our website. And the requirements is you just need to download the Archicad, sorry, Python 3.7 or later. Then make sure you have Archicad 24. This library will not work in 23. So make sure you use 24. This is a good time for you guys to upgrade your software. Okay. So if you really get lost on the documentation, we have one immortal here in Singapore, which is Martin. He helped me a lot on the API side. He's a C++ guy, but he knows Python as well. This guy is immortal. Okay. Yeah. So if you want to dig deeper, we also have JSON. Okay. So JSON is a JavaScript object notation. Okay, so we have this API as well together with Python. Okay, so just a quick user interface on the Python interface. So actually, this is very simple. So how to locate first where is Python after you install your Python in your computer, and then go to Archicad 24 work environment and make sure you turn on the Python palettes. Okay, this is under experimental features, enable Python palettes. Okay, just make sure to turn on that. So once you have it, go to your window, palettes, and then you will see the Python palettes below. So once you click this Python palettes, it will show you this dialog box. It's very simple. We have these gears on top to check your connection. So if you want to check where is your Python, Archicad will automatically look for your, if you want to check your location, where is the Python installed, so you have this here, okay? So make sure it's updated. And then if you want to browse and look for your file, again, Archicad Python is running externally, not inside Archicad. Okay, so you can always use your Visual Studio. You can use Jupyter Notebook to create the code. Okay, so just click this folder here to open your .py file. Okay, so before you run your script, make sure you click refresh and then hit the run button. Okay, just a quick preview on that one. So this is the problem that Jorge gave me. So now the plan is to automate the morph line. This serves as the grid or a method framing in Jorge's project. So we need to name this grid first. Okay, so we're gonna use this graph. We're gonna name this as X and Y. Okay. Then the next step is to, once we have that information in the morph line, now the next step is to get the intersection. So we need to automate the object. in the firefly's light or the pendant light. So we need to automate the object element ID naming based on the XY morph line element ID. Okay, so I will just explain in a very simple way. So for example, we managed to name the element ID. For example, this is y-axis and this is the morph line, and then we managed to name it. And then what we're gonna do is assign this x5 to the object name. Okay, so again here, so let's say we managed to get the morph line name, so we need to assign this y8 to the object name. So again, we have two, x5 and y8. Okay, so these two. Okay, so this is the plan. I hope it works. So the first plan is to get the bounding box. So just give you a quick schooling about elements. So everything in Bim, I mean every element has bounding box. Okay, so take note on that one. So this is the plan now. We're gonna get all the bounding box, including the object. Okay, this is some of the API docs function. Later I will flash the code. Okay, this is just snippets. Okay, that's the plan. So get the bounding box of the object, get the bounding box of the morph x, and then get the bounding box of the y. Okay, so just to explain it to you, so in Archicad API Python, so every object has bounding box, right? So this portion we call it x min, and the other side is x max. Okay, so again, this is like a coordinates system of object bounding box. So again here, this is the y min and this is the y max. Okay, about the object, let's pretend that this is the object light. Okay, the pendant light. Okay, then the next step would be getting the morph bounding box. So let's start with this vertical. So just a quick info. Again, we have if we have a line, so this is the y min and this is the y max. Okay, but of course we still have a x min equals x max because this is still x, but we don't have height, right? We don't have max. So but we still have the x because there's no displacement. Okay, so that is the horizontal vertical morph, similar to horizontal morph. So we have a minimum and a maximum and the y min and the y max. Okay, but of course this is equal because we don't have height. Okay, if this one is square, then that means we have the value of y max. So that's why I put y min equals y max because we don't have y value here. Okay, that is really important. Okay, this is the code. So this is the first plan. So we need to segregate the morph, then name based on the configuration. The configuration later I'll show you. Okay, so it's a local variables. Okay, so this is the plan. So we need to segregate where is the vertical and where is the horizontal. Okay, so we need, I'm not gonna teach you how to write Python, but I'm just gonna explain to you how this one works. Okay, so what we did is create a loop and condition so that we can segregate the y and the x. Okay, so once we segregated the y and the x, which is the horizontal morph and the vertical morph, now we have the opportunity now to set the ID for horizontal. So we have the y min and y max, if you still remember. So now what we're gonna do is get only the horizontal morph line, okay, and then set the ID. Okay, so that's what we did here. Then after that, again, get the vertical morph because we successfully segregate them, and now I could create a list and create a condition to set the ID. Okay, so that is the first step I need to do. So now once I have this two morph line, which is the y and x, this is the tricky part. Okay, so we struggle a lot here how to, because we don't have geometry intersect in Python for now. So this is the struggle we're facing, me and Ralph. So trying to find a way to ask Python to detect where is the object. Okay, so this is what we came up. So this is the simple statement here on top. Okay, so if the morph bounding box, okay, so this is a morph bounding box, passes through the object bounding box y, okay, uh, okay, object bounding box y, it means this one, okay, this line, okay, don't get confused. So y max and y min, this is the object bounding box, okay. So again, if morph bounding box passes through object bounding box y axis, which is this one, and object bounding box is within. So this we have another function here. So we have this information here, right? So we have x min and y min. So if the object is within this line, then the answer will be true. So what I mean is it passes through the first statement. So this one is qualified. Okay, this object is qualified for naming, but we still need another one. Okay, so again, we only have x. We still need to get the y to verify the location. Okay, so again, we created another condition. Now this time is to if the bounding box passes through the object box x, again, object is the blue one, and box x-axis is this one, okay, this line, okay, and the object box is within y, so within this line. Now I successfully locate the location of the object. Okay, so now I have two conditions. I have one, okay, hold on. Yep, I have one condition here, which is true, then another condition here, which is true. So now we successfully verify the location, and this object is qualified now for ID. Okay, so this is the simplest way how to explain this automation part. Okay, so now the next part would be get original element ID of the object and its corresponding horizontal and vertical morph. Okay, so we did some string manipulation here for the X chord and Y chord. Then we create a if condition. Okay, so to set the new element ID based on the morph line. Okay, so that's a very simple explanation on how we manage to locate the ID and name it. Okay, I have a simple video here, but later I'll show you if we have time. Okay, this is the problem that Jorge passes to me. If you do it in manual process, it will take ages, right? Okay, so now with this Python API, it helps a lot. So you notice the element ID of every morph has no ID. Okay, it's really, they're all the same. So that's one problem we have. Then the object, if you check the ID, again, we do not have ID for the element. Okay, this is the tedious process. Let me do some verification. So I will select all the object and automatically label all. So we have this tool in Archicad to label everything in one shot. Okay, because I need to check and verify all the IDs. Okay, let's zoom in a little bit, and now you see no ID. Okay, this is the problem now I'm facing. Okay, so with this Python, it helps me automate this process. Okay, so we have two problems. The morph line doesn't have ID and the object doesn't have ID. Okay, so go to work environment. Make sure you enable Python palettes. Click OK. Then go to Window, open your palette, and then click the Python palettes. Okay. So now Archicad will search for the python.exe. Now I have the palettes here. Of course, if you want to load and locate your Python, just click this folder. If you want to delete and refresh, it's here. Okay, again, the Python is created not inside Archicad. You need to use other ID like Visual Code or Jupyter Notebook, so it's up to you. Then you just need to run here, okay? This is just checking the connection. You see the python.exe location is here. Okay, so that's it. Then now it's time for the magic. Okay, let's run this script and see if this one will work. Okay, refresh and see the console is showing. Okay, so now Python is running and trying to automate the whole process. Okay, we have two paths. One pass would be the morph naming, second pass would be the object naming. Okay, so now we have successfully rename it based on the coordinates. Okay, you notice we have this object name, that is the object name now, and on your right you will see morph, right? That's the, and next one will be the ID of the morph. Okay, we have pan x something, so the other side is y13. So we had successfully automate the process. Okay, the naming process. Okay, let's verify and see if everything is okay. Yep.
Wow. This is great stuff.
Yeah, but we burn like, half of our brain cells is dead now.
Yeah.
To figure out this one, luckily we have Chidam and Ralph here to help me. Okay, so yeah, this is the process. Then I will show you the code, but of course I'm not gonna teach you how to write Python. I'm just gonna go through with you in general. Okay, so let's try to modify the code a little bit and change something. Okay, let me open up the code. Before we open up the code, let's check the schedule first and making sure the ID is properly assigned. Okay, so this is all the objects, element ID, everything is okay. Yep. Then
you have the length of the cables and then the name of the.
Yep.
Yeah.
Okay, so that is how it works. Now let's try to open up the code and then do some configuration. So we have this configuration here. So this is a local variables. If you want to rename, for example, I want to rename the name of the object, then I will just save it. We do have some debugging here using the print, just like Ralph mentioned, but I will not turn on that one. So this one is the position of the coordinates. If you want to start from top to bottom, or you want to start the other way around. Okay, that is x. Okay, x and y. Yeah, so this is the whole code. Not gonna explain all, but just splashing on the screen for you to check. Yeah, a bit complicated because there's a lot of conditions we need to met. Okay, so yeah, let's save it. Okay, and then go to your Archicad again, then search for this file. Okay, so I'm using the same file in the folder, so I just need to refresh this. Okay.
Yeah.
Yeah, click refresh and make sure you see this refresh console, and then click run.
So instead of light, now we should say thank you. Is it?
Yep. Thank you to BCA and everyone.
Yeah.
Yeah, I hope it works, but still loading. Yeah, it takes a while to understand, but thank you. There you go.
Great job, thank.
Yeah, so
Thank you, Carlo.
yeah,
It's a fantastic job.
that's it, and let's move on to the question and answer, I think.
Yeah. Great stuff. Guys, amazing timing.
This
Yep.
is, you don't know how much time we spent dealing with this ID and later. You have no idea. No idea. Actually, we have one guy in the office that spent almost one night doing IDs for another part of the aquarium.
Yeah, that's the tedious
Doing
part.
one by one, yeah.
Imagine you have thousands of elements, right?
Yeah.
Even there's some automation inside Archicad, like to understand the logic of the project and to make the IDs follow the logic of the project. It's really good that these tools are out there, and the beauty is that we can use this script anytime, right? And we just
Yeah,
need.
it is like you need to have set of scripts, and you always modify and run based on the design. Yeah.
Yeah, I see a lot of potential in this. So
Yep.
yeah, great
Yeah,
stuff,
true,
guys.
true, sure,
Really
sure,
nice.
sure. Yeah,
So
so maybe
yeah, this is
sorry, go
a
ahead.
shut up and take my money moment, right?
Yeah, exactly.
Yeah,
Okay.
okay, so thank you very much. I'll pass the screen to Marcelo.
Okay.
Okay.
Well done, guys. So I would like now to open up the yeah. So I'd like to open up now this timing for a question and answer. So if somebody has questions, just let us know. We would like to try to address it. Again, I would like to highlight that this will be available on our YouTube page. So you can choose to follow us and in social media. So under Graphisoft SG, you can find our page. We have a bit over 90 subscribers now. This was really in the beginning when we had started this like a couple of months ago, and we really want to start putting like localized content and things that are more customized. A lot of user case studies, like just like how Jorge shared from Enzyme. So please sign up for it, and we'll keep you guys posted. So if whoever has questions, just shoot it, and we'll be happy to address your queries. If you want to contact us parallelly, you have our emails here, our direct contacts, and just can reach out to us. So this hello, we are Enzyme. Jorge is always on top of this, so you can reach him there. So green is Enzyme, orange is Graphisoft. Okay, so yeah, let us know if there are any questions, guys. I think everyone is still blown
Okay.
away.
Yeah. Marcelo, there's some question coming on the chat.
Yeah.
So Rui is asking, the API gives access to all the properties of Archicad elements and objects.
Not for now, right?
Yeah, not all yet.
At the moment, no, but it's building
But
up.
yeah, you
So
can see from the web page, they are going to slowly improve it. But just to share with everyone, the concept of Python connection is very similar to Grasshopper connection to Archicad. So they will be slowly adding additional functions, and it is not only for, because I think Carlo also mentioned about JSON API. It works very similar, and you can use any language and use JSON part to control Archicad. So it is not going to be only Python. You can also use other languages to access it. This is what I understood. So definitely there is more options coming for custom solutions, customization. So
yeah. Okay, so
yeah,
everyone
Carlo is really master. I know you're right.
after.
No, no, no.
I
Still
think
need to learn a lot.
I think guys, there is an interesting question in the chat.
Yep.
I don't know if you mind if I bring this up.
Yep,
Uh,
sure.
I think Rui or yeah, Rui was asking if it's possible to run forms and interfaces in Python. And I mean, I've seen a couple of videos in YouTube of someone, I think from the US, that is already doing this. So I'm not sure if you guys are familiar with these videos, but he's creating an interface that will pop up once they click the run the script. So
Yeah. I also see a Ralph answer for that. You can spawn UI using the
Yes. Yeah, you can use this
Tinker
mod.
library.
Yeah,
Yep.
you can use this library or module, the Tinker. to have
Yeah.
that
That's
interface.
that's a bit of additional information. Yeah. Jorge, can you share the links to that YouTube?
I'm looking for them because I saw them
Sure.
on LinkedIn last week.
Oh, okay.
I'm trying to think where they are, but they were very interesting because once they run the script, it will get a like a pop-up window where you can, for example, choose among certain parameters, maybe to or maybe you can go and open an Excel file or something like this. You know, like give a
Yes,
bit.
we saw that in HQ. So actually, if you check Martin's reply, actually this is the one that they use. They use this Tinter library to have that UI or dialog box that you mentioned.
That's perfect.
Yep.
Thanks. I'm gonna try to find the links.
Yeah, and Leonardo is asking, Rhino inside would be possible with this Python plugin. I don't know. I
I'm
am not.
not familiar.
Yeah.
Jorge, would you understand this? You have more understanding of it?
I mean, the Rhino inside, I think it's just a different concept. If I understood well, Rhino inside, what it does is it you can sort of like install the library of Rhino, of the Rhino commands. I don't know how that is the it's called, the not the API, but actually it works sort of similar to what it does the Grasshopper connection. Obviously it has more reach inside the the Revit set of commands, and so you can reach more functions. But I think that probably if from HQ they enrich the library of actions that you can do in live connection, it will be very, very similar, because it actually the connection works with JSON, right? It's a JSON.
Yeah.
Yep. Yep.
So I think it's a similar concept, just using different libraries.
Mm-hmm.
Yeah, I saw some reply from Clover. They did mention about ECGUI API, and then Ru mentioned about the PI Simple GUI. Yeah, this is some
Yeah.
of the libraries or modules that we can use. Thanks.
Yeah.
Ay.
Okay. Yeah. And Ralph also highlighted that it's like a Python scripting, and you can use any libraries available for Python scripting, and you can get the things done, right? So it's yeah, I agree with Ralph.
Yeah, there's another question.
Guru is asking, is it possible to select objects from Archicad's canvas from the script?
Okay, last time we do have this get selected elements in Archicad 23, but I think now we don't have it yet. When I check, we don't have, but last time I saw that get selected elements.
So
that
basically,
means,
select on the script, and you will
yeah,
highlight elements in Archicad.
select first, and then you run the script.
Yeah. Well, as we mentioned before, this is a development that is continuous. I would say we are in in the early steps of the released version, but we expect more and more to come out with this.
Yep. Yep.
And I think it's good this way because the users can start using it like this preliminary form, and then once they get more comfortable to it, the tool itself will start having more and more options for them.
Yeah, initially, earlier there was also a question between asking whether it is only available in 24. We did reply that, yeah, 23, it was like a technology preview, Python part, right? So then we were trying something using like a wrapper. This is what I understood. but now they are going to use very similar concept as Grasshopper connecting to Archicad. And I think they will be able to grow quite fast because they already have the experience doing the Grasshopper connection. I think we can expect more functions coming out soon. Yeah. Any other questions?
I think everyone is drained after such a long day. So everyone is thanking for the
presentation. Yeah.
It's a pleasure.
Yeah.
Again, we
won't
would
be
like
yours,
to
yeah.
thank PCA for having the And one more thing, we would like to highlight that this is the first out of 4 series. So as you can see here in the screen, we'll have on the 13th of November digital fabrication. We'll try to continue with the same project so that there's some continuance to the work that we're showing. And next year we'll have 2 more sessions based on digital construction and digital assets delivery and FM. So if no further questions, would like
there is
to.
one. Yeah. Rui is asking, is it possible for developers to know how the connection works? I'm not sure whether that details is available. We can check if it is available. We can share. Yeah.
Yeah, and possibly even connect them with the developers from our HQ.
Yeah.
I don't know what is the purpose. If you'd like to become a developer or something like that. But we can follow up again when I shared our contacts. This is one good example of what we can look into. So guys, if this is it, I would like to wrap up the session here. Special thanks to BCA for helping us and to Jorge for supporting Chidam, Carlo, and me in this initiative. Ralph also gave us a little bit of his devoted brain to programming for this session to be successful. So thanks a lot, everyone, and looking forward to meet at the next event.
Yeah. Thank you, everyone. Thanks for joining. Yeah, some of you from different time zone. I understood.
Yeah.
Thank you very much. Thank you for BCA and
you.
Pong also.
Guys.
Thank you.
Thank you, guys.
All right.
Thank
Stay
you,
safe.
Thanks, team. Very good job. Thank you.
Very much.
Hey.
Bye.